in understanding. Like when you do MCQs, it's like a revision of the topics. Not today. Like 2-3 seconds, I will discuss unit MCQs, and then I will start. Like next session, we'll do unit 5, which is about MCQs. MCQs of unit 5 first. When you're coming for the class, that time, like for your online session, I will do the structure. Which one is? Okay, this question.
What is
This is January 2022. 2022, yeah. A simplified Born-Haber cycle for a formation of a lithium iodide is shown. So usually in a Born-Haber cycle, where the two arrows are pointing it out, that is the start of the cycle, where two arrows are pointing in, that is the end of the cycle. So if we follow route 1 or we follow route 2, the overall energy change is independent of the route or the path we follow. The enthalpy change of atomization of iodine is 107, is given by, what is the meaning of the term atomization? Atomization means when we produce 1 mole of atom in a gaseous state. So what is the state of iodine at room temperature? From element in their standard state, when we produce, like here we will have iodine. So what is the state of the iodine? Iodine is solid at room temperature. When we produce an iodine atom, what we call that as atomization. So which one refers to atomization? 1 mole of atom of iodine is formed. So B is representing the atomization. Next is use the information in the cycle, calculate affinity of iodine. How we can calculate the affinity of iodine? This is unknown. Like here we will have iodine solid. And here we have iodine gas, yes.
It's like M7, right?
If
the others going up, it's
into them. So here we have a iodine gas. Where the two arrows are pointing out, that is the start of the cycle. Where the two arrows are pointing in, that is end of the cycle. So if I follow route 1 or I follow route 2, the overall energy change is independent of the route or the path we follow. So I will just simply add 160 plus 107, then plus 520. This is 160. Because I have to take both, like the full. Because we have the lattice energy of lithium iodide, which include the lithium also. First lithium is atomized and then lithium is ionized. Then iodine is atomized, then iodine is affinity happen for iodine. And then this is the lattice energy. So it's because both ions we have to include. That's why 160 plus 107, then 520 plus X plus minus 729. So it will minus 759. And then this is root 1 is equals to root 2. So it is minus 207. We need X. So we move everything other side. So X will be equals to minus 207 plus 759 minus 520 minus 160 and minus 107. What's the answer here when you simplify? So negative 298. So the affinity means when electron is added to a neutral gaseous atom. So
there was 2 electrons. Then this value will be multiplied by 1 by 2.
If 2 electrons are there.
Yeah, if 2 electrons are multiplied by 2.
Yeah, if 2 atoms are there. Like, let's say if we were having 2 atoms of here, 2 atoms. then this value will be multiplied by 2. If it was like, let's say it was a magnesium iodide, okay? So magnesium iodide, first we'll have a magnesium, and then we'll have iodine, from iodine atom.
Yeah.
But because we need, so this is atomization and then ionization, the magnesium plus 2 will be there and it will form a 2 iodide ion. So this affinity will be multiplied by 2 in that case. Because for one ion is X, for 2 it will be 2X.
If there was some there will be a second electron.
Second electron, not multiply by 2, because second electron affinity is not a multiple of first electron.
One will be more exothermic than in the case of the second problem.
First affinity is always exothermic, second is endothermic.
Yeah.
Because the electron, we have to supply energy to add electron to that.
Yeah, I remember you go down.
Down.
Then
Up. So this will give us the enthalpy change. So A will be the answer. Yeah, A is the answer for that.
That's the reason for the second electron to be thermic.
Like charges repel, so we have to overcome the repulsion. Like oxygen took 1 electron. Oxygen is negative, electron is negative. So we have to overcome the repulsion. That's why the second electron affinity is endothermic. We have to provide energy so they come closer to each other.
Since after removing the first electron.
Not removing, adding. Affinity is addition.
But it will be more repulsion.
Yeah, more electrons. So negative charge repel negative charge.
So
we have to supply energy so they come closer and electron could be gained.
To overcome like that.
Repulsion. Some energy changes are given in the table, as you can see a table. Use the data to calculate the enthalpy change of hydration of calcium. So first, when we write the equation for this, a calcium chloride form calcium ion, 1 calcium ion and 2 chloride ion. Okay. So the enthalpy, the formula is that the enthalpy change of a solution is equals to hydration minus the lattice. That's a formula. So enthalpy change of a solution is given to us, that is minus 120 to minus 120. Then the hydration is for both ions, the hydration for calcium and hydration for chloride. So hydration for chloride is for 1 mole of a chloride is minus 364. So for 2 moles, it will be 2 times. So calcium is X. The hydration means when water molecules surround the ion, we call hydration. So for calcium, the hydration is X. And for chlorine, the hydration is 2 multiplied by minus 364. Minus the lattice energy. What is the lattice energy here? The lattice energy is minus 2,258. So this is the lattice energy. This is the hydration energy. So we simplify for X. So it will be minus 120 X minus 720 plus 2,258. Then we move other side. So minus 120 plus 720 minus 2,258 is equals to X. How much? So B will be the right answer. Why we multiply for a chlorine by 2? Because there are 2 moles of chlorine ion. Minus 120 plus 720 minus 2,258 is equal to X. Why we multiply by 2? Because it was forming 2 moles of the chloride. If it was forming 1 mole of a chloride, then we will not multiply by 2. The next, the reaction shown, is it in equilibrium? The forward reaction is endothermic, which will increase when the temperature is lower. If we increase the temperature, the rate of a reaction will decrease, the equilibrium will shift towards the left-hand side for endothermic reaction. So amount of a carbon dioxide and the carbon will increase, and amount of carbon dioxide will decrease. The mole fraction of a carbon dioxide. Mole fraction.
Mole fraction between, which will increase now, sorry.
So the mole fraction, like more moles of a carbon dioxide will be there.
So
Greater proportion.
So the law favor the sun.
Partial pressure of a carbon monoxide. Carbon monoxide partial pressure will decrease because its moles are decreasing. Because the partial pressure is the moles of a gas divided by total moles into total pressure. Because if the moles of the gas is decreasing, the partial pressure will also decrease. Total will be same. The number of moles of a gas are also same, but the partial pressure is decreasing. Then rate of forward and backward both will decrease because they're decreasing a temperature. Rate is always decreases with temperature irrespective of forward or backward. And Kp for the forward reaction, the value of a Kp is a product divided by reactant. Like the pressure of a product divided by pressure of reactant. Because the pressure of the product divided by pressure of the reactant. So pressure of a reactant is increasing and the pressure of a product is decreasing. So what will happen to the Kp? The Kp will decrease, not increase. Clear? Because Kp depends on the pressure exerted by the product molecule divided by pressure exerted by the reactant molecule. Because we will have more reactant and less product, so the pressure of the product will increase and the pressure of the reactant will decrease. Sorry, pressure of the product will decrease and the reactant will increase.
So like Kp was the pressure, the sum of the pressure. So
no, Kp is the ratio between the partial pressures of a product and a reactant. Like Kp is the pressure of a carbon monoxide square divided by pressure of carbon dioxide. I did not include carbon because it is solid. In a Kp, we don't include a solid, only gases. So because the partial pressure of this one is decreasing and carbon dioxide is increasing. So what will happen to the Kp? The Kp will decrease.
no, I mean the Kp is like partial reactant or
Ratio between a Kp is an equilibrium constant, which is a ratio between the pressure of a product and reactant. Then at 680 degrees centigrade and 1 atm, 52.6% of a molecule in the gas mixture are carbon monoxide. What is the partial pressure of a carbon dioxide? Look, as we know, when we write the expression for Kp, (52.6%) is the pressure due to carbon monoxide when the total pressure is 1 atm. What will the partial pressure of carbon dioxide? We know the total. Yeah, the total partial pressure. So remaining, what will the partial pressure of a carbon dioxide? Because percentage of a carbon, two gases are only exerting a pressure. One is a carbon dioxide, another one is a carbon monoxide. And
so like
52.6% is because of the carbon monoxide. So remaining percentage is due to
47.6.
so 47.6, 47.4. So 47.4% is due to carbon dioxide.
Yeah.
Then we'll find 47.4 of 1 atm. So it will be 47.4 times 1 divided by 100. It's actually like 47.4 divided by 100 into 1. It's the same thing. So C will be the right answer. Why we did not include a carbon here? Because the carbon is a solid. Solid does not contribute to any partial pressure. Only gases contribute to partial pressure. Partial pressure is only
Affected by
here. and the mole fraction. If the mole fraction change, the partial pressure change.
Yeah.
If the temperature change, the equilibrium changes, so mole fraction also changes, so the partial pressure also.
So like
Change.
temperature,
Yeah. And it is obvious that, or if you change the total pressure, then the equilibrium shifting, that will also affect the partial pressure. Kp and Kc is only affected by temperature. Partial pressure is different thing. Look, don't be confused with the term Kp. Kp is not partial pressure. Kp is the ratio at equilibrium. So when the reaction is at equilibrium, the value of the Kp will be constant. If I change the temperature, the value of the Kp will change.
So Kp is the one which is called affected by temperature.
Temperature.
But P by the mole fraction and
yes, right.
Is it the equilibrium or something?
Position of equilibrium also.
I mean, that's in the mole fraction.
Yeah, that's I'm saying it's the same thing. What is the unit of equilibrium constant? First, we identify it's a heterogeneous equilibrium because aqueous solid. So we don't include a solid. So it will be 1 because product is nothing is there and the reactant is lead ion and the chloride ion. The 2 is there. So, and what is the unit of the concentration? Mole per dm cube. So Kc is over. This will be mole per dm cube. And this will also be mole per dm cube and square. Whole square will be there. When we simplify 1 over mole is cube because this 2 and dm cube 9. Move other side. So dm cube will be 9 and mole minus 3. So dm cube 9 and mole minus 3. So A will be the right answer. Why? Because this is aqueous in a solid. So as a result, what will happen? This is a heterogeneous equilibrium. Heterogeneous equilibrium means different states are there. So we only include aqueous and a gas. We don't include solid or a liquid in a heterogeneous. So when we write the Kc, the expression, it will be only the reactant, not the product.